Hello students, today I am going to start with another design problem or design chapter. It is design of earth retaining structure. Mainly we are going to design here retaining walls. So initially we will study what is this retaining wall and what are the types of this retaining wall. So what is this retaining wall? The retaining wall or the earth retaining structure are generally used to retain the earth or such materials to maintain unequal levels of its two faces. Means let's say by the roadside we may be observed that a vertical structure will be standing and behind that vertical structure large earth will be retained. Large quantity of earth will be retained. So what is the use of this retaining walls or earth retaining structure is that the movement of the earth will be restricted by these earth retaining structures or the retaining walls. So here the soil is the material which is applying the force on the such earth retaining structures, and the soil which is on the other side of this retaining wall or the earth retaining structure is called as backfill. So the soil on the back face is at the higher level and is called as backfill. So it may be perfectly a horizontal level or it may be having certain inclined. So this material, the horizontal material which is backside of this retaining wall or retaining earth retaining structure is called as backfill. And retaining walls are extensively used in the construction of basements, that is below the ground level. We may observe these retaining walls in case of underground structures also, or let's say in the construction of basements also. Let's say there is a total of 15-story building and the ground floor and G plus 2 structure may be constructed, then we may be or we will be going for the construction of these earth retaining structures. So if they are not constructed, these earth retaining structures are not being provided or not constructed, what will happen? The earth will not be retained at a vertical as a vertical section. It will collapse because of the unsupported thing, and it exert the pressure on the elements. So, in order to maintain this verticality or vertical surface and take care of this horizontal pressure that is being imposed on the elements, so we are going to construct these earth retaining structures. So in this particular chapter, we are going to study about the design of these retaining structure, earth retaining structures. So they will be constructed or they may be required at the construction of basements below the ground level, wing walls of a bridge. At the bridges they are required, and to retain the slopes in hilly terrain roads. As I said, we need these in case of hilly terrain roads as well as in case of roads as well as railways. We need the we require these retaining walls to retain the material behind this vertical element, that is retaining walls. The retaining walls prevents the retained earth to exert a lateral pressure on the wall, tending to bend, overturn, and slide the retaining wall. So what happens because of this earth that is being stored behind this vertical element, that is retaining walls? Now onwards I am using the word as retaining walls. So this earth will exert a pressure. So this lateral pressure will be there on the wall, this retaining walls, and which will make the retaining wall to bend, or it may be overturning, means completely it will overturn from its base, and sometimes there may be sliding of the retaining wall also. So we must take care of all these things, that is bending, overturning, and sliding. So retaining walls should be designed to resist the lateral earth pressure, and we will be maintaining or we will be restricting this bending, overturning, or sliding of the retaining walls. So Thus, we are going to resist the lateral earth pressure from the sides and the soil pressure acting vertically on the footing slab and integrally built with a vertical slab. Means here I can say that it is an cantilever slab. The retaining wall, I can say this retaining wall as a cantilever slab, and this cantilever slab is having free end at the top side and bottom it will be fixed. Right? What is cantilever? Cantilever means one side it will be free end and another side it will be fixed. So cantilever slab will be having one fixed end and another free end. So here also this is a fixed end, means it is fixed to the ground at one side and another side at the top it is free. Here we are having four types of retaining walls, earth retaining structures. So first one is the cantilever retaining wall, means as I said, it will be like a cantilever slab. At the base it will be fixed to the ground and at the top it is free. And second type is called as counterfort retaining walls. Counterfort retaining walls means we are going to provide the vertical walls, cross walls to the retaining walls. So these cross walls will uh, restrict the movement, or they are going to uh, restrict the horizontal pressure that is coming over the retaining walls. That is another kind. And if in the same thing, that is, if I want to show that, here we can observe that. So here is the counterfort retaining wall. This is a type, second type, that is counterfort retaining wall. So in this case, this is the soil, that is backfill means this is the soil, and towards the soil we are going to construct such a vertical inclined walls. These are vertical and inclined walls. So these are called as counterfort. So if we are constructing or if we are designing such cantilever, such a retaining walls, then they are called as counterfort retaining walls. And if we are having the such counterforts which are called as buttress, so if we are constructing the buttress opposite side of the backfill, then it is called as buttress wall. So that is the difference between counterfort retaining wall and the buttress retaining wall. So in the counterfort, this vertical wall will be constructed towards the backfill, and if it is constructed opposite to the backfill, then it is called as buttress wall. And a first basic type of retaining wall is the gravity wall. That is the construction of a thick wall along the along the length of the retaining material, that is earth. So these are the four different types of retaining walls. Out of these four, we are going to study only the cantilever RC retaining wall. Okay, what is this cantilever retaining wall? We study in depth. It is the most common and widely used retaining wall of the cantilever type, and it comprises of the following structural parts. Means what it consists of mainly. So it is having a vertical member which is called as a stem. So vertical stem resisting the earth pressure from one side, and the slab bends like a cantilever. Means vertical element, as I said, it is like a cantilever slab. So that slab element will be called here as a stem, and there will be slab here at the base, which is as a which this entirely will act as a cantilever slab. The thickness of the slab is larger at the bottom, and gradually it decreases towards the top in the proportion of the variation in the soil pressure. Means at the top soil pressure will be small, and at the bottom soil pressure will be large. So it is as like the water pressure which we are studied in the fluid mechanics. So at the bottom it is a triangular, soil pressure will be triangular in shape, and at the top it is zero and maximum will be at the bottom. So at the bottom this slab thickness or the stem thickness will be provided larger, and at the top we are going to reduce it. That will be gradually decreased towards the top of the cantilever slab. Then second part is the base slab. Base slab forming the foundation comprises of the heel slab and the toe slab. Means at the bottom it is fixed to the ground. So this is the base slab, and this base slab is comprises of two parts. One is the heel slab and another is the toe slab. So heel and toe, what we generally get the meaning, that is the same here. So the heel slab acts as a horizontal cantilever under the combined action of the weight of retained earth from the top and the soil pressure. Means here it is a heel, and toe means it is the front side, right? So this heel slab will be retaining the earth above this, and it is going to carry the earth pressure as well as the weight of the retained earth. So weight of the sulfate of the earth will be carried by this heel as well as the soil pressure acting on the this heel slab also. From the top of the from the top, and soil pressure acting from the top, it means from the base. So there will be two things. One is from the base, again soil pressure will be there, and at the top again the sulfate will be there as well as the soil pressure is also acting. The toe slab acts as a cantilever under the action of resisting acting under the action of the resulting soil pressure acting upward. Means here the toe is the front part of the this cantilever retaining wall, and here there will be upward soil pressure acting on this toe slab. See here it is, I have mentioned the soil pressure acting upward means it is not going to support anything. It is just a support provided so that it will not overturn or it will not bend. The stability of the wall is maintained by weight of the earth fill on the heel slab. Means how much earth is being retained on the heel slab, it is going to stay, or it is going to maintain the stability of the entire structure. So self-weight of the structural elements of the retaining wall will be the toe slab, heel slab, and the stem here. Then cantilever type retaining walls are adopted for a small to medium height up to 5 meters. Means what we are studying is restricted to the height of the such a retaining walls will be restricted to an height of 5 meters. Up to height of 5 meters we are going to study. So here the figure of retaining wall is being given. So this vertical member is the stem here. It is a upright slab which is this entirely we can say this as an cantilever slab. This is the vertical member which is called as stem here, and this is the toe part, and this is the heel part, and this heel will be sustaining the dead load of this earth fill as well as the pressure acting on it, and the toe slab will be having only the soil upward soil pressure here. So next type is the counter force retaining walls. We will not going to study about this in depth. So you can observe the elements here. These are the counter force provided. This is the heel and this is the toe. Means if these vertical members or the counter force are provided at the soil side, then it is a counter force retaining wall. If it is towards the toe part, then it is called as buttress retaining wall. So that is the difference between these two kinds. So students, now we will learn more about the cantilever type retaining walls. Okay. First terminology what we are going to study is the angle of repose of the soil. So soil embankment or the cutting has a tendency to slide downward and come to a rest position, right? When the soil slides, it will be having certain inclination when it comes to a rest position. So this inclination or the slope of the soil is called as the angle of repose of the soil. That is the first terminology which we are going to study. Then we have what is this retaining wall. The structure which is constructed to retain the earth or any other loose material which are unable to stand vertically by themselves are called as retaining walls. So what I have already discussed is the same one. So when we want to construct a building, let's say ground floor will be constructed and below that basement if I want to construct, the loose soil will collapse there. So in order to retain that loose soil, I am going to retain the loose soil by the construction of these vertical members which are called as retaining walls or the earth retaining structures. The materials retained by the wall may be level or it may be inclined at a certain angle with a level surface of the wall. Means at the vertical element, this at the end of the retaining wall, the soil or any material that is being retained, it may be having a perfectly level surface or it may be having any inclined surface. So the inclined fill is known as surcharge. That means the material which is above the level surface, it is called as surcharge, and the inclination with the horizontal is called as angle of surcharge. So we have two angles here. One is the angle of repose, that is the it is the by nature what is the angle of the soil, or what is the angle made by the soil in its rest position, that is called as angle of repose. That is one angle here, and another is the angle made by the surcharge, means that is the infill. It is the filled material above the horizontal surface of the earth, or it is the inclined fill above the horizontal surface of the earth, and it is having certain inclination. So this inclination is called as angle of surcharge, which is related to the surcharge. And the wall is acting upon by an outward push from the earth retained behind, and it is called as earth pressure. What is earth pressure? It is the pressure exerted in a simple manner. It is the pressure exerted by the soil behind the vertical member, that is the retaining wall. This is called as earth pressure. So after that, we have studied what are the types of these retaining walls. We have four types: gravity wall, cantilever RC type retaining wall, then counterfort retaining wall, then last one is the buttress wall. Now we will study about the active earth pressure. What is this active earth pressure? And then later on we are going to study about the passive earth pressure. So what is this active earth pressure? Active earth pressure, which is also called as soil earth pressure, or it is earth pressure, is the pressure exerted by the retained material on the retaining wall. Means it is the pressure exerted by the material retained by the retaining wall, and this pressure will be acting on the retaining wall. So this is called as active earth pressure. In simple manner, it is a pressure exerted by the soil on the retaining wall. It is called as earth pressure or active earth pressure. And this earth pressure will tend to deflect the retaining wall outward. Means there will be retaining wall. So here you can see, or okay, here is the retaining wall, and this is the earth pressure, and this earth, okay, this is the earth here, and this earth is going to, okay, this is the earth, and this earth is going to push this retaining wall. So this is the earth pressure. So this is the earth pressure, and which is acting towards the retaining wall. So this earth pressure will make the retaining wall bend outside, and this earth pressure is called as an active earth pressure. The earth pressure exerted on the retaining wall, the earth pressure exerted on the retaining wall depends on different soil conditions. So different soil condition means we have mainly four soil conditions here. One is the dry or moist level backfill. Then second one is the submerged level backfill. Third one is the backfill leveled but subjected to the uniform pressure or uniform surcharge. And last one is the backfill with sloping surface. So first one is dry or moist level surface or moist backfill. Means there will be even or leveled backfill behind the retaining wall. That is the first case, and the soil will be completely dry. There will not be any water content. That is the first condition. Second condition is submerged leveled backfill. Means here the earth will be there, and this earth may be contain certain quantity of water. There will be water content in the earth. So this may be completely submerged, means water will be there at the top of the till the top of the this retaining wall, or maybe up to certain height of the retaining wall. Then that will be the submerged level backfill. It may be completely submerged or it may be partially submerged. And third one is the backfill leveled but subjected to uniform surcharge. Means let's say there will be, it is a first condition, it will be a first condition, plus there will be extra surcharge placed, or extra force or the load is placed over the backfill. That is the third case. And fourth case is backfill with a sloping surface. Third case is having uniform surcharge, but fourth case is having backfill with a sloping surface. So these are the four different cases which we are going to study. So first one is the dry or moist level backfill. So here I have shown in the figure this is the retaining wall here, which we are going to consider. This is the only stem which I have drawn here, and bottom there will be this is a stem and there will be slab here. So here is the toe and here will be the heel. And let's consider the total height of the this retaining wall as capital H, and I'm going to consider the small h as the height up to which I'm going to consider the pressure. So here capital H is the height of the retaining wall at the top of the surface from the bottom, and the intensity of the active earth pressure or intensity of the active pressure per unit area of the retaining wall at any depth below the top of the wall is being given by PA equal to Ka gamma into H. So here earth may be up to this level, earth may be up to this level, earth may be up to this level, or maybe up to this level. So we are going to consider this h, small h, from the top of this, and this much up to certain height we are going to consider, and up to that height we are going to calculate the pressure. So for example, let's say earth is being retained up to this height, then the triangle, this pressure triangle will be only from this height to base of this retaining wall. So this will be the only earth pressure triangle. So when I am going to consider, this is the h here I am going to consider, and the remaining thing will be capital H minus small h. So let now consider the total h. So when I am considering this total h, so this total h is equal to small h. So this total earth pressure will be gamma a Ka into gamma into h. That is the pressure at the bottom of this triangle. And what is the total force acting on the retaining wall? This will be gamma into this, that is the area of this triangle into unit unit meter distance. So that will be gamma, that will be Ka into gamma into h square by 2, that is the area of the triangle, into 1 meter length we are going to consider. So total pressure acting will be at a place where the centroid of this triangle lies. So centroid of the triangle will be, it is 1/3 of the total h, that is the total height of the retaining wall. So total height is capital H, and 1/3 means h by 3. So this will be acting from the base of the this triangle, that will be h by 3, and total force will be Pa is equal to Ka into gamma into h square by 2. That is the pressure, that is the force acting. So the intensity of the earth pressure per unit area of the wall at any depth below the top of the wall is given by Pa, that is the pressure at certain height, small h. So it will be Ka into gamma into h, right? So that will be Ka into gamma h at a particular height. And when I want to calculate it to the complete height, then it will be Ka into gamma into capital H. But when I want to calculate the total pressure at any height h, that will be given as small Pa, that is active earth pressure, equal to half, that is the area of the triangle here. So this is the triangle, and h is the small height here, up to which I am going to consider the height. So it is half into base into height. So half into base, that is uh, okay, half into base. Base is Ka gamma into small h. So here again it is Ka gamma into small h. That is a base into half into h. So it will be h square. So it will be total pressure acting at particular height small h is equal to half base, that is Ka into gamma into h, into height. Height is small h. So totally it will be half into Ka into gamma h square. So when the force is acting at a height h by 3, and if I want to calculate what is the force acting at this particular height, that is the center of the gravity of the triangle, that is acting at an h by 3, then the total force or the total pressure will be calculated as, it is Pa. Okay, here I have written, it is Pa is equal to Ka gamma h square by 2. That is half into base into height. That is the total pressure acting per meter. So here we have Ka into gamma. What are these terms? We will see now. Where Pa is equal to intensity of the earth pressure, active earth pressure, gamma is the unit weight of the backfill, phi, it will be there in the calculation in next step. So phi is the angle of internal friction of the soil, and K is the coefficient of active earth pressure. So we have two coefficients. One is the active earth pressure coefficient and another is the passive earth pressure coefficient, that is Kp. So Ka is equal to, it is 1 minus sine phi. So what is phi? Phi is the angle of internal friction of the soil. So it is Ka is equal to 1 minus sine phi divided by 1 plus sine phi. If I want to calculate passive earth pressure, then it will be 1 divided by Ka, which means Kp is equal to 1 plus sine phi divided by 1 minus sine phi. And when I want to calculate the bending moment at the base of the wall, because the this soil pressure is going to cause the bending, or it is acting at a certain height of the cantilever up to at a certain distance from the base of the slab. So what is the bending moment at the base we want to calculate? So it is force into distance. What is the force? Force is the area of the triangle. So it is half into base into height. So it is half Ka into gamma into h square into h by 3. Where it is acting? It is acting at an height one third of the total height of the retaining wall. So it is h by 3. So bending moment is equal to Ka into gamma into h cube by 6. So h square into h, it is h cube divided by 3 into 2, it is 6. So total pressure per unit length of the wall is equal to the area of the pressure distribution diagram, and it is given as I have explained, it is given as Ca is equal to Ka gamma h square by 2. That is the total pressure, or it is a force acting at particular distance. And it is acting at a center of the gravity of the pressure triangle, that is at a height of h by 3 above the base of the retaining wall. So this is about the calculation of active earth pressure. So students, up to this, go through these terminologies and the small part of this calculation. Remaining things we are going to study in the next lecture. Thank you.